All right. Hey guys, I'm Sean.
I'm Matt.
Trish. Katya.
I'm Connor.
We're Team Bouncer, and we've been working on a device that detects drink tampering.
Yeah, so according to a 2014 study in the UK, 1 in 10 people say they've had their drinks spiked, and that problem is a lot closer to home. As you all received an email from Tufts in late February, the campus advisory about drink spiking. I don't know if you all remember that, but it's clearly an issue, and it's an issue here, so we're trying to address that. So our solution is to give users the ability to monitor their drink if they leave it alone and protect it. So we have up here 3 sensors. It's an accelerometer and gyroscope and a stretch sensor, which we'll talk about a little bit later. Those send data to an Arduino, which transmits that data via Bluetooth to our app, which processes all the data, detects if there's been a tampering event, and there's also various other settings for the user, which we'll show in the demo.
So being the human factors lead, my goal, or actually my task in my second semester, my senior design, was to conduct a series of evaluations of our prototypes, both software and hardware. So we completed the first round of usability testing about 2 weeks ago after receiving IRB approval as our entire engineering psych and human factors class together. And so you can see some stills here just from some of the footage that was captured during testing of participants interacting with both our initial hardware prototype as well as some mock-ups of the mobile interface. Go ahead. Slide. So after that was done, we had to analyze the data, generate a usability report, and summarize all of our findings and recommendations so that we could proceed with prototype improvement. So here's just an example of one specific set of findings and recommendations for a specific design feature related to the physical device. So there's parallel tables for both the physical device as well as the mobile application. This is kind of one of the most important ones as we try to accommodate a varying range of container sizes all with one device. And yeah, so as I said, now we're still in the process of just trying to get our prototypes to the next level where they're more usable, have higher fidelity with what they'll actually look like by the end of the semester. And for our next round of evaluation, we'll be doing expert reviews, hopefully using Professor Lasser's son, who's an industrial designer, as well as someone else for the mobile interface.
So here's what we have now. And you can see on your left that there's an earlier prototype where there's no electronics in here, but we have the idea of having a skirt of sorts and a lip of conductive rubber. And this is the prototype that we'll be demoing for you today. And before I move on, I'll also bring up this one would integrate the stretch sensor, which is not in there right now just for demonstration purposes today. How it works is that you use the switch to turn it on, and then you can then put it on your glass and use your phone to activate or deactivate it to start sensing and processing data.
So we've been collecting some data with our different sensors. Some samples of it is in this first graph. Here's some accelerometer data. So accelerometer measures acceleration in the X, Y, and Z directions. So for this trial, we tried to lift our prototype off 3 times, and you can clearly see the 3 spikes in data. So that's what we use to actually gather our thresholds. Right next to it is some stretch sensor data, and even though that is not on this prototype that we'll show you today, and this is a trial of just us putting it over a glass and moving it about a quarter width away from the glass, and you can see how the spike, when the resistance and the sensor changes when you stretch it.
Cool. So that takes us to the demo. Feel free to turn it on. See if we can get this to display. Oh, nice. So we've got our bouncer app there. So right now we're not connected. So the first step would be to go to your settings in the top right, go to your Bluetooth, and right now it's called HM Soft. You can just ignore all the blank spaces. I don't know why that happens. HM Soft is us. So now we can choose to activate the device, and that will cause it to start sensing. So if we press
low energy Bluetooth or
low energy, yeah. So I just pressed activate and deactivate, and you can go to your history tab, and that'll show you what's happened to your device recently. It'll show. So this is just now, but this is like an example of if there was an alert for if tampering actually occurred, it'll tell you. And the whole point of this is to give the user a better idea. If something goes wrong and someone messes with your drink, you have an idea of when it happened. And then there's also the Friends tab, which is not fully operational right now. It's right now just list your contacts. But the idea was that when you go out into a social setting where you're drinking, you're going to be going with friends. And if someone spiked your drink or someone tempers with your drink, you would want them to know about it, so they could help you out in the case of an issue. So you would be able to select friends from your contacts here to also notify in the event of a tampering incident. But hasn't been implemented yet. And then the last page is just for us. It's not going to be in the production app whatsoever. It's a testing page that we use to gather data from our sensors. So we actually went out to Restaurant Davis and set everything up on the table, and we gathered about an hour's worth of data. And we're still in the process of analyzing it. And we're going to use that to better determine our threshold for detection. So we can actually activate it now and try lifting it up. And it says, hey. So you can choose to either dismiss it if maybe you just inadvertently knocked it over or something and you're like, yeah, no one tampered with it, that was me. You can dismiss it. Or if you actually were gone and, oh, hey, this is actually someone messing with my drink, you can hit report. And then you can verify your location. You can contact someone. Ideally, you would be able to contact one of your friends that you listed, but like I said, it's not functional right now. So you can choose to contact the police if you want. We'll go with yes. And then you can enter anything else you wanted to about your thing. Yeah. And you can, and then once you submit, that sends it to us, and then we'll have all that information saved for our record keeping. And that's that. Cool. Back to this. So what we weren't able to finish, like I said, the social integration aspect had started, but didn't get a chance to finish that. I did mention security a lot last semester in terms of encryption. Didn't get a chance to implement it, but that's something that's vital for to actually turning this into a real product to stop people from deactivating other people's devices or messing with the data that's being sent from the Arduino to the phone.
As we talked about earlier, the stretch sensor and the other sensors aren't integrated yet into one prototype. We're still working on that, but that would definitely improve our detection algorithms. And once we do that, that'll be better. And also just collecting more data and really fine-tuning those thresholds and algorithms will help us.
And lastly, unfortunately, we weren't able to make it into a scalable form. Right now, we have it in the 3D printed case, which, as opposed to being a manufactured mold that you could crank out in a manufacturing facility, we have our components on a proto board instead of on a PCB, a printed circuit board. So that means that we went to a prototyping retailer like Ada Fruit or SparkFun, bought their components off the shelf and made it work to our purpose. That would be significantly more expensive than if we were to make it scalable and have the components be bought from a supplier, bought in bulk, to really minimize cost. So our next steps would be to go to an investor or a manufacturer and to use their expertise and resources to really put it to the next level.
So further work on the software side, I already mentioned the security encryption thing, and then also the improved detection algorithm once we incorporate the stretch sensor, which we hope to plan to do in the next week or two, and actually be incorporating that sensor. And then in the future, someone would need to be doing extensive testing on the device to make sure there are no loopholes, no way to game the system. There's also the settings page on the app, which I showed you guys the Bluetooth part, but the other parts like customizing alerts and notifications and sounds, none of that's implemented yet. And then right now the history log thing that I showed is saving to a web server, so technically you need Wi-Fi to use that feature. And ideally, you would just save that to the phone's local storage and then use the web as a backup.
Right, and on the hardware side, we were hoping that the processing would be done on the device, perhaps in case you go out of Bluetooth range. And so first we need to make sure that perhaps Bluetooth is all right, and we need to confirm that or not. But if it's not, then processing should be done on the device. And the reason why it's not currently on the device is because the phone has much better throughput for these sort of algorithms. So as we go through different filters and different ways of setting a threshold, we would want it to be done on the phone to not waste computation on the device. Once we have that filled out, we would put it onto the device, and hopefully it would be very efficient so that we can get lots of data. Secondly, we would want an electronic display for the user, something that's a little more intuitive, something like a LCD screen that can tell you the state of the device, when it's active, when it's off, when it's inactive, and then we would of course want to put on our stretch sensor, our second method of detection. Right now you saw the accelerometer working, and that would prevent from false positives. The stretch sensor would be both an electromechanical way of protection. It would detect if somebody were to try to peel it off, and it would also help secure to the glass so that you can put it on pretty much any container. Lastly, the aesthetics need to be changed so that it's very attractive to consumers. We could shrink it down to make it less heavy, less plastic, less expensive. If we were to do the steps I said earlier about scalability, and we would manufacture the casing in a more robust way so that it's protected against environmental harm, say like falls or dust or water.
Cool. Anybody have any questions?
I'm wondering how much the parts cost right now. You mentioned you wanted to scale it down.
Yeah, the accelerometer board that we used was about $40. It was like a breakout board from SparkFun.
Bluetooth was like
Bluetooth
$10.
was like 10.
Batteries are about 10.
It's a good amount.
Yeah.
Not super
They have
marketable.
like $5.
It's just a lot of little things that just add up.
Yeah.
Well, you could get it down much.
Oh,
cheaper.
yeah.
Mhm.
100%.
Yeah,
Yeah.
you could definitely do it.
Walden?
You should keep the big metal switch. Because it's like pretty intimidating. See, like, oh crap, like, it's like a bear trap with gloves. Not much of a question.
That was actually sort of something. So if somebody turns it off, does it alert you that it's been turned off if you haven't specifically deactivated it yet? You'll lose your Bluetooth and it will pop up.
It'll tell you if you lose Bluetooth
You'll know
connection.
if it happened. Okay, just in terms of like this. Yeah. And it wouldn't look like this. Like it wouldn't be a switch. I mean, right. But like if somebody turns it
Maybe it
off
will.
and then like took it off
Yeah,
and then
that's
separate it and
separate.
then turn it back on.
Yeah.
Whatever.
Just because you guys are the only team with a human factors person, was there any conflict between the engineers and human factors to kind of figure out through the capstone, so like what was
Every day we fight. No, I think we each have our own like deliverables for our own classes, but I think we kind of manage those independently, and I think we work pretty cohesively. Is that specifically your question?
That's a good answer.
Yeah, I think for this type of project, it's really useful.
Yeah. I mean, what's funny is, if anything, we're still kind of understaffed in that we don't have people who are really like hardware specialists. We're kind of trying to be without like maybe the proper education, but yeah. So.
Of like industrial,
Yeah, sorry. I'm just talking about like the plastics and the latex and yeah.
I think this is a really cool presentation. I do love the fact that you had that many capstones integrated into one project. I think that's really cool. And I think the device came out, the device is great. The app looks more robust than I thought it was going to be, so very good.
There we go.
Very good. Any other questions?
Wait, is this a project with a patent that you're working on?
Yeah.
Be careful.
What happens if your phone gets out of range of the device? Does it start storing on?
That was the thing that Matt was talking
Oh,
about.
okay, cool.
Right. So right now the processing is done on the phone because the throughput's better.
Okay.
Yeah. Ultimately, I would want it to be done on the device instead.
All right, good job, guys.